Welcome back to Chemistry 1, Unit 4, Lesson 1 on electrons, and this is video 2. So the last video we talked a lot about some of the properties of electrons. Now we're going to talk about how we can use the placement of these electrons in the electron cloud, talk about how atoms interact with one another. So the first thing we're going to do is talk about valence electrons. And what this is an electron in the outermost energy level. So we're talking the ones that are at the edge of our electron cloud for the atom. So these are the ones that are exposed to the outside world. The other ones are kind of in towards the middle. So we're only going to be looking at these electrons in the outermost energy level because these are involved in bonding or making compounds. And if we went through the whole process of electron mapping, we would see that an atom can only have a certain number of electrons in its outermost energy level. And that level is going to be 8. So this atom wants to have 8 in its outermost level because it would be full. This makes the atom stable. And this is true for almost every single element, except for hydrogen and helium. They only need 2 valence electrons to be stable. So what we are going to be doing is using a notation called electron dot diagrams to map out the valence electrons. And we're going to use this the whole way through this unit. And this is a fairly long unit. So what we're going to do is we're going to use the symbol for the element. And because it's an electron dot diagram, we are going to use dots to represent electrons. And there is a special way that electrons fill this shell. So I'm going to draw an X here. And I'm going to put a 1 and a 2 together. Then I'm going to do 3, 4, 5, 6, 7, 8. So the first 2 electrons pair up. The next ones go in 1 per side until all spaces are filled. And again, we would have to take about a week or 2 to go through how electrons map in order to explain this. You'll just have to take my word for this. And I know that if you had Mrs. Bowman, you went over this. But it's more stable if the first 2 pair up in 1 energy level, and then these represent other energy levels that we have for the electrons. So they go in 1 at a time until they have to pair up again. So you might say, well, that's fine and dandy, but how do I know how many electrons are going to be in something? Well, we are going to use our handy dandy periodic table. So you need to take out your Flynn periodic table. And we are going to see that the periodic table, its shape, why it looks the way it does, is based on electrons and how they are placed into energy levels. So with that, we're going to put a big number 1 above the column that says hydrogen, a 2 here above the column number 2, and then we're going to skip the whole way over here and put a 3 in front of or above boron, a 4 in front of above carbon, a 5 above nitrogen, a 6 above oxygen, a 7 above fluorine, and an 8 above helium. So we have 8 of these tall columns on the periodic table. We have 8 slots for valence electrons. What this number tells us is how many valence electrons there are for the elements in that column. So everything in the first group here, hydrogen down through francium, has 1 valence electron. Everything in group 2, the whole way over to here, and including everything down here, has 2. Everything in this group, from boron through nihonium, has 3, 4, 5, 6, 7, and 8. And a lot of you know that group 8 we call the noble gases. Well, there's a reason for that. And we'll talk about these groups a little bit later. So, you have numbered your periodic table as demonstrated. So let's look at an example. If we have the element aluminum, and we look on the periodic table, we see aluminum is right here. It's under the column that says 3, which means we have 3 valence electrons. So sometimes they say, what is the valence number of aluminum? Well, it's 3. So we're going to put the symbol of aluminum. We know that the first 2 electrons are paired together. So to write its dot diagram, I'd have 1, 2, and then one of them is placed by itself on one of the other sides. Let's look at astatine. Astatine is symbol AT, and it is right here. So we look to see that it is in column 7. So it has 7 valence electrons. So the first 2 get paired together, 1, 2, and then we have 4 or 5 more to put in there. So 3, 4, 5, 6, 7. And that would be its dot diagram. So now you should go through and work on this worksheet, electron dot diagram worksheet, where you're going to draw dot diagrams for these 10 elements and then answer these 4 questions.